Welcome back. This is the second part of the Silksong tutorial movement series. In the first part we set up basic movement, and if you haven't already, I highly recommend watching it first to get a good understanding of what's going on. In this video we'll be looking at more advanced stuff like wall sliding, jumping and climbing, and dashing and sprinting. Optionally, at the end of this video I will correct the float state from the previous video to make it feel more floaty. Don't forget to join the Discord server where you can get help, ask questions and chat with others. And without any further ado, let's get into it. The wall slide state. In Silksong, when unlocking the cling grip ability, Hornet is able to cling to walls. When moving into a wall, she first comes to a full stop and then she starts sliding down. Her sliding speed increases over time until it reaches a certain threshold, after which the speed remains constant. Wall sliding also resets her ability to perform a double jump. Before we can program any new states, we should add them to the state enum. Add wall slide, wall jump, wall climb, dash and turning. We prepare for wall sliding by adding a new raycast to our scene. Let's rename it to wall slide raycast, place it around shoulder height and point the target straight in front of the player. Make sure it goes past the edge of the collider. In our script, let's add the raycast to it by making the node accessible as unique name and drop it into the script. Remember to hold down Ctrl upon dropping to easily create a new onReady variable. Next, we need two new constants. First, the wall slide gravity with a value of 300.0 and then wall slide velocity with a value of 500.0. To finalize our preparation, let's come to the bottom of our script where we've defined the handle movement function, and inside we want to flip our raycast upon turning around the same way we did with the ledge climb raycast. Just copy and paste it and replace ledge climb raycast with wall slide raycast. Quick tip, if you select a property and then press Ctrl+D a few times, you'll subsequently multi-select the same property, which you then can adjust at the same time. Then let's add a new simple function to check if we can wall slide. It should return true when isOnWall is true and when the wall slide raycast is colliding with something. Let's move over to our switch state function. In the section used to handle state-specific things upon entering that state, add our wall slide state. Upon entering the wall slide state, we want to play the wall slide animation, set our Y velocity to 0, and to reset our double jump, set canDoubleJump to true. In the process state function below, let's also add our wall slide state to the list. For the movements, just copy and paste the first two lines of the float state and replace the float constants with the wall slide ones. The wall slide state can currently transition to three other states. First, when we land on the floor, we should switch to the floor state. Second, when we find a ledge and there's enough space to fit the player, we transition to the ledge climb state. Third, when we are no longer able to wall slide, for example due to any gaps in the wall, we switch to the fall state. Only two states should transition to the wall slide state. At the bottom of our fall state, add a new elif statement that checks if an input is given toward the facing direction and if we can wall slide. When both conditions are true, transition to the wall slide state. Simply copy the if statement and transition and paste them at the bottom of our float state. When we open our scene, Tiny McStick figure should now be able to cling to walls and slide down from them. Since our double jump should reset each time we cling to walls, if you time it correctly, you should already be able to hop your way up to higher points. But this is not the actual wall jump. In order to correctly perform a wall jump, we first need to visit the wall jump state. In Hollow Knight, when you slide down a wall and press the jump button, you'll perform a wall jump. Just like the normal jump, you can hold down the jump button to perform a full jump or cancel out by releasing it earlier. In the first part of the wall jump, for a certain distance, you're diagonally forced away from the wall regardless of any given input towards the wall. After that distance, you're free to move back. We need to prepare a few things for the wall jump state. First, the constant wall jump length with a value of 30.0. This value will be the horizontal distance in pixels that the player is forced to jump away from the wall. Then the constant wall jump velocity with a value of -500.0. We also need a variable, saved position, that starts at vector 2.0. We will use this vector to calculate the distance between our player and the wall. At the bottom of our script, we want to create another function. When jumping away from the wall, our character is forced to face the other way. So we will call this function setFacingDirection, which requires a parameter called direction. This function should take care of flipping the sprite, setting the facing direction variable, and raycasts like we already do in the handle movement function. So we can simply cut that section out, paste it into our new function, and replace input direction with just direction. We need to adjust one more thing to the handle movement function. Instead of making it a local variable input direction, we want to make it a parameter instead. And this parameter should then default to 0. Inside the function, check if it's equal to 0, and if it is, we assign the input value like normal. We can now replace the part we cut out by calling setFacingDirection and passing input direction along with it. Now, upon calling the handle movement function, we can choose to provide a value that will force our player into a certain direction. If we provide 0 or don't provide anything, the function works like normal. At the bottom of our switch state function, let's define what should happen upon entering the wall jump state. First, we need to play the jump animation and set our Y velocity to the wall jump velocity constant. This is also the moment we want to force our player its facing direction away from the wall. We can achieve this by calling the setFacingDirection and inserting negative facing direction. Lastly, set the value of saved position to the current position. The wall jump should behave almost the same as any other jump, so in our process state function, simply provide it next to the jump states. We do need to change something though. Before we call handle movement, let's check if the active state is the wall jump state. If this is true, we calculate the distance over the x-axis between the current position and the saved position. The wall jump is finished when the distance traveled becomes greater than or equal to the wall jump length, or if can wall slide is true, which can be the case when wall jumping between two close walls. Then we directly change the active state to the normal jump state. This will cause the wall jump to continue as a normal jump when the wall jump part is finished. When the wall jump is not finished, we call handle movement and force the player into the facing direction. Below this section, in a new if statement, when the active state is not the wall jump state, we call the handle movement function like normal. To finalize the wall jump, we need to add a single transition from the wall slide state to the wall jump state. Inside the wall slide state, use an elif to check when the jump button is just pressed, and on true, switch to the wall jump state. Dynamic stick figure should now be able to cling to walls and upon pressing the jump button, perform a wall jump. With this new ability, we are already able to do some very neat parkour. But wall jumping won't be the only way to move up the wall. So let's look at the next state, which is the wall climb state. In my own playthrough, I noticed this mechanic very late into the game. But when you hold down input towards the wall and press the sprint button, Hornet performs a wall climb. Notice that if we perform a wall climb that travels over a ledge, the wall climb is continued into a ledge jump. Since the ledge jump is performed without pressing the normal jump button, we can perform a double jump during the ledge jump, which cancels the ledge jump. First, let's make sure that our input map contains the sprint action. Go to project settings and in the input map, make sure sprint is added as an action and that a key is bound, which in my case is the shift key. Back in the script, we'll start with two new constants again. Wall climb velocity with a value of -300.0 and wall climb length with a value of 65.0. Upon entering the wall climb state, we want to play the wall climb animation, set the Y velocity to wall climb velocity, and update our saved position, which we'll use to calculate the vertically traveled distance. Below in the process state function, add the wall climb state. In here, we first calculate the distance like we did in the previous state, but this time for the y-axis. Then, if the distance becomes greater than or equal to the wall climb length, or when we hit a ceiling, set the y velocity to 0 and switch back to the wall slide state. In an elif statement below that, check if we find a ledge during the upward motion, and if so, we transition to the ledge jump state. In the wall slide state above, add a new elif statement that checks if the sprint button was just pressed, and when true, perform another check to see if the player is holding down input towards the facing direction. If that is also true, it should switch to the wall climb state. To perform the ledge jump cancel I talked about earlier, come up to where we handle the jump states, and at the bottom, add a new elif statement that checks if the jump button is just pressed, which can only be true during a ledge jump after a wall climb. Let's take a look at TinyMac's stick figure again. When we hold down input towards the wall and press the sprint button, he performs a wall climb. This concludes the vertical movement of the tutorial. Let's focus a bit more on the horizontal movement, and we'll begin with the dash state. When we press down the sprint button, Hornet dashes. She travels a very short horizontal distance incredibly fast. When dashing in the air, there is no vertical movement, so for a brief moment she's flying. However, she can't dash again until she touches the floor or any walls. The dash has a set travel distance and there's a small cooldown to prevent spamming it. When you press the jump key during the dash, the jump is buffered and performed directly after the dash. This buffered jump also has a coyote timer. During the wall slide, when not holding down input towards the wall, and pressing the sprint button makes her dash away from the wall. What is interesting about dashing away from walls is that you are still able to dash again in the air. If you continue to hold down the sprint key, the dash continues into a sprint, but we'll look at sprinting in the next chapter. We'll start preparations by adding a new timer node to our scene. Rename it to dash cooldown, and in the inspector, let's set the process callback to physics, the wait time to a small value, and enable one shot. After that, add it to the script. You probably guessed it at this point, but we need more constants. Add dash length with a value of 100.0 and dash velocity with a value of 600.0. Then for variables, we need canDash and dash jump buffer, which both start at false. In our switch state function, 3 states should reset the dash upon entering. Those states are the floor state, the ledge jump state, and the wall slide state. Let's add the dash to our enter state section. First of all, make sure to return to the previous state when the time left on the cooldown is greater than 0. Below that, start by playing the dash animation and set the y velocity to 0. Call the set facing direction function and pass the current input direction along with it. We can now use the facing direction variable multiplied by the dash velocity constant to update our x velocity. Update the saved position to the current position so we can calculate the traveled distance. Whether we can dash again depends on the previous state. If the previous state was either the floor or wall slide state, canDash should remain true, and we can simply assign those two conditions to our canDash variable. Last but not least, set the dash jump buffer to false. At the bottom of our process state function, add the dash state. In there, we reset the dash cooldown timer, and for as long as we remain on the floor, we should also reset the coyote timer. I should mention that I updated my coyote timer wait time to 0.1 seconds, whereas the previous value was 0.2. Then we enable the jump buffer upon pressing the jump button. We need the horizontal distance between the current and saved position again and use it in an if statement that checks if it's greater than or equal to the dash length. We should also check that if for whatever reason the x component of our last motion doesn't point in the same direction as the facing direction. This is usually because the player hits a wall, but if it's something else, we don't want our player to be stuck in the dash state. And when one of those conditions turns out to be true, we should switch to other states. Transition to the jump state when both the jump buffer and coyote timer are active. If not, transition to the floor state when the player is on the floor, and otherwise transition to the fall state. The dash state should directly be able to switch into the ledge climb and the wall slide states. When we go back one scope in a new elif statement, check if there is a ledge and if there is plenty of space to fit the player. If so, switch to the ledge climb state. In another elif statement, check if we can wall slide, and on true, switch to the wall slide state. Finally, we need 5 transitions to the dash state for it to work. The first one is in the fall state. At the bottom, add a new elif statement that checks if the sprint button was just pressed and if we can dash. When true, switch to the dash state. Now we can simply copy this section and paste it at the bottom of our floor state. Though we can remove the can dash condition, since we should always be able to dash when on the floor. We can also paste it in the jump state and in the float state. For the wall slide state, it's a bit different. We want to dash away from the wall when not holding down input towards the facing direction. So in a new else statement, flip the facing direction and switch to the dash state. And that should be it for the dash state. Let's see how Tiny Mac's stick figure is doing. When we press down the sprint button, he should simply perform a dash. And he's able to do so when falling down, whilst floating, and away from the wall. Okay, shall we implement sprinting? Sprinting. Like I said earlier, when you keep holding down the sprint button, the dash continues into a sprint. This sprint continues through falling, when on the floor, and when jumping. The sprint is stopped when letting go of the sprint button, when performing a double jump, when floating, and when hitting a wall. Interestingly, when you do a ledge climb while holding down the sprint button, you'll start sprinting without dashing first. Sprinting is not a state, though we do need to start by adding constants for it. First, sprint velocity with a value of 400.0 and sprint acceleration with a value of 1800.0. We also need a new variable, is sprinting, which starts at false. In the switch state function, we want to disable sprinting when entering a few states. Upon entering the double jump state, the float state, the ledge jump state, and the wall slide state. Let's once more go to our handle movement function. In the function declaration, we want to add 2 more default parameters. Horizontal velocity, which defaults to the walk velocity constant, and step, which also defaults to the walk velocity constant. Then change the way we adjust the x velocity. We'll assign a move toward function, which moves the value of x velocity toward input direction multiplied by horizontal velocity by the value of step. When we now call the handle movement function, we can choose to provide different velocity and step parameters, which we will use to make the sprinting feel smoother. When you call the function without any extra parameters, it works the same as before. Below the handle movement function, create a new function called handle sprint, which takes delta as a parameter. Inside it, we call handle movement. We set facing direction as the first parameter. This forces the player to sprint in the direction they're facing. As the second parameter, we provide sprint velocity, and as the third, sprint acceleration multiplied by delta. Here we should also change the value of is sprinting. We want to keep sprinting when the sprint button stays pressed, and when we do not run into a wall. Make sure it says is action pressed and not is action just pressed. Let's apply sprinting to the states. First, when processing the fall state, we check if is sprinting is true. If so, we call the handle sprint function. Don't forget to pass delta along with it. When we are not sprinting, we should call the handle movement function like normal. Inside the floor state, we'll do essentially the same thing but with animations. When is sprinting is true, play the sprint animation and call the handle sprint function. In a new else statement, just highlight this section and add an extra indent by pressing tab. In the jump state, also the same thing. Check for sprinting and then call the handle sprint function. Make sure to change this if statement into an elif statement. To finalize sprinting, inside the ledge climb state, is sprinting should be toggled on or off whether we hold down the sprint button or not. This makes sure we can sprint after climbing on a ledge without performing a dash first. Then just copy and paste the same line into the dash state which is needed because you might only want to dash without starting a sprint. Let's look at our player. When we press and hold down the sprint button, Tiny Mac's stick figure should first dash and continue sprinting after. And with it, we can actually jump the gap from the first video without using our float ability. Now we're only missing the last piece of the puzzle, which is the turning state. Lucky for us, the turning state is a pretty short one. And I hear you ask, why do I need an entire state just to turn around? It's because the Hornet is only able to turn around on the floor, and when she jumps while turning around, she does a neat backward somersault. So, for our preparation, we need to add a new function, which is somewhat similar to a previous function. Copy the whole isInput toward facing function and paste it below. Replace toward with against and add a minus before facing direction. We need this function to turn the player around when the input is against the facing direction. Upon entering the turning state, we'll only have to set the facing direction to the opposite of its current value. When processing the turning state, it's a different story. During the turning state, we should be able to decide to turn around again. We should do this by checking if the horizontal velocity direction matches the facing direction. This will force the player to fully turn around before being able to turn around again, if that makes sense. Then we should also check if the input is against the facing direction. When both conditions are true, we should flip the facing direction. For our movement, we can simply call the handle sprint function. Then we need a few transitions. There's this possibility where the player tumbles over the edge when turning around. So if the player is no longer in contact with the floor, switch to the fall state. In a new elif statement, we should define what happens when turning is finished. The turning is finished when we stop sprinting or when the x velocity multiplied by the facing direction becomes greater than or equal to the sprint velocity constant. When this is the case, switch to the floor state. The last state transition should happen when we decide to jump. So when the jump button is just pressed, we play an animation. I didn't make a backward somersault animation, so I'll just use the double jump animation. Then we disable sprinting and switch to the jump state. To make sure the double jump animation runs correctly, upon entering the jump state, we need to prevent the normal jump animation from running when the previous state was the turning state. To finish off the turning state, we need one final transition from the floor state to the turning state. Inside the floor state, add a new elif statement that checks if the player is sprinting and if the input is against the facing direction. When true, switch to the turning state. And that should do it. Tiny Mac's stick figure can now dash, then sprint, turn around, and do silly dances. More or less. Correction. The controller is, of course, not exactly one-to-one with the controller in Silksong, but it should give you a general idea of how to build one. Regardless, I have a small correction to make inside the float state. First, notice the difference between my controller and the one in Silksong. Notice how smoothly the Hornet travels from side to side when changing the input direction, whereas my controller reacts instantly. To change this, add another constant to the script called float acceleration and give it a value of 700.0. Down below, when processing the float state, adjust the handle movement call by passing the following parameters. First, 0, because we don't want to force our player into any direction. Second, the walk velocity constant. And third, float acceleration multiplied by delta. This acceleration factor is what causes the smooth floating. And if you check it out in the game, floating should feel very floaty. Now that we've built this amazing character controller, you might still have some questions, such as how does the state machine work and what is the best way to write my own states? All the answers you're looking for can be found in this video. Go click it.